Hello and welcome to screencast number 4. In this screencast we're going to look at how these fossil fuels are refined. We're going to consider the diversity of uses in the fossil fuels, and we are going to take a look at what it means if we deplete our fuel reserves. So let's start with the refining part of this. In order for us to be able to use the oil or gas, it needs to be processed and refined. So crude oil, we're going to take a look at that first, will be shipped to the refinery. When we study it chemically, it is a complex mix of hydrocarbons and can create many types of petroleum products by separating its various components. Many types of the hydrocarbon molecules in crude oil have carbon chains of different lengths. And these different lengths give the different parts of the oil different chemical properties that has subsequent uses for. So in order to get those different lengths of hydrocarbons out, we need to refine them. That's the process. And this is where hydrocarbon molecules are separated into different size classes and are chemically transformed to create specialized fuels that we use for heating and cooking, we use for transportation, and we use to create lubricating oils, your asphalts on your driveways and your roads, and the precursors of many of the plastics and other petrochemical products. So let's take a look at this process. Okay, so here's the distillation columns at an oil factory, and the inside of the distillation columns look like this. There's several levels and there's ways that materials can move upward through them. Not easily. As you see, it's not a direct path here. So in A, what happens in picture A is that the crude oil, and let's just go over to A here, the crude oil is going to be boiled, and this causes the hydrocarbon constituents to volatilize and proceed upward. Okay, then in B, they'll enter this distillation column that you see here, and the constituents that boil at the hottest temperatures and condense readily once the temperatures cool will condense at low levels in the column. Constituents that volatilize at cooler temperatures will actually continue to rise through the column, so they'll work their way up through the column at higher levels where the temperatures are cooler. This is where we get our heavy oils from. These generally, the heavy oils are those that have hydrocarbon molecules with long chains and are separated from lighter oils. And lighter oils generally have those with shorter chain carbon molecules. So when we see butane, butane is a shorter chain compared to fuel oil, which is a longer chain. So the higher up you go, the shorter chain molecules or properties, constituents as they're called, are going to be separated out so that you can get these different types of grades of fuel from the crude oil. When we take a look at picture C, this is the typical composition of the refined oil. These show the percentages of each major category of the product that is typically generated from a barrel of crude oil. So we can see heavy fuel, liquefied petroleum gases, jet fuel, diesel fuel, and heating oils, and then gasoline that we can get from the crude oil. Okay, let's move now from the crude oil to the coal, and we'll also talk about natural gas. So coal, oil, and natural gas are used in our society today, as everybody knows. Coal is actually going to be burned to cook food, to heat homes, to fire pottery. This has been used by many cultures over thousands of years. We've used coal-fired steam engines that helped drive the Industrial Revolution. It powered factories and agriculture and trains and ships by fueling the furnaces of the steel industry. And we burn coal largely to generate electricity today. This is where our electricity comes from. We have coal-fired power plants and coal combustion that converts water to steam, which turns a turbine that creates electricity. And coal provides about 40% of the electrical generating capacity of the United States. It also powers China's surging economy, and China is now the world's leading primary producer and consumer of coal. So taking a look at this graphic, this is what happens. We bring the coal in, and it goes into this bunker where it will be ground and it will be pulverized, and it will be put into this furnace and lit on fire. This is the ash. This is going to be what we get after it burns. And this pipe has water in it, so this is going to heat the water that's passing through these pipes. And as it heats the water, it's going to power this turbine, making it spin, and that's going to generate our electricity. So now what we have to do is we have to also be able to take this steam and condense it back into water and cool it down so that it can be pulled back in again and boiled. And we also have this filter system that is going to filter out any smoke that comes, and that's what comes out of the smokestack, and then we dispose of our ashes. So this is the way that we use coal. So now let's consider natural gas. And natural gas, as we're going to hear, is considered to be a bridge fuel because we think that it's the fuel that we're going to be able to use that will bridge us from using fossil fuels to sustainable energy choices. It's very versatile and clean burning. It emits just half of the carbon dioxide per unit of energy produced as coal, and 2/3 as much as oil. Natural gas is used to generate electricity in power plants, to heat our homes and to cook, and it's used for many other things. It's easily converted to a liquid, which at low temperatures, which makes it very easy to transport and ship. The liquid form is known as liquefied natural gas, or LNG, and you've probably seen that around somewhere before. We replace coal with a natural gas to generate electricity, and this cuts our carbon emissions in half. So that's why many experts view natural gas as the bridge fuel, as I mentioned before. And they say that it's the bridge leading from today's polluting fossil fuel economy toward a clean, renewable energy economy for the future. Where does the United States stand in all of this? The United States and Russia lead the world in gas production and gas consumption. So we do the most. Okay. So here is a data table that just shows the use. China leads in coal use. Saudi Arabia leads in, or production I should say. Saudi Arabia leads in oil production, and the United States leads in natural gas production. As far as consumption, China consumes most of the coal, with the United States running in second, but a distant second. The United States uses the most oil, so we're supporting Saudi Arabia in their oil. China, as you can see, is second, but not a very close second. And in natural gas use, the United States leads in that, and Russia is in second place for use. So oil is the next one that we have to consider, and our oil use began roughly about 1859 when the world's first oil well was drilled in Titusville, Pennsylvania, again right here in our own backyard. Over the next 40 years, Pennsylvania's oil fields produced half of the world's oil supply and helped establish a fossil fuel-based economy that that would hold sway for decades to come, and that the world depended on. Today, with our global society producing and consuming nearly 200 gallons of oil each year for every man, woman, and child, so that's 200 gallons per person, per capita, that's being used. The majority of this is going to be used to fuel our vehicles. So gasoline for our cars, diesel for our trucks, jet fuel for our planes. Some homes burn with oil. We have an oil tank that we no longer use. We use natural gas and wood to heat our home. But industry and manufacturing still account for a great deal of oil use. One of the good things is refining techniques have improved, and chemical manufacturing have greatly expanded our uses of petroleum to include a wide variety of products and applications. We use them to make plastics, to lubricants, to fabrics, and even pharmaceuticals. There are petroleum-based products that are all around us that we use in our everyday lives that we don't even think that we're using, and petroleum is used to create so many items and materials that we really rely on it, and it's vital to our lifestyle. So we need to make sure that we conserve our remaining oil reserves if we want to continue to have these products. When we think about how much is being consumed, oops, this just gives you an idea of how much we use petroleum. Our cosmetics and medicines, our plastics, your toothbrush, your shower head, anything that has nylon in it, clothing, your light switch, pesticides and fertilizers, things that make bicycles, your tires and your upholstery in your car, your dishware, containers that you use, your paraffin waxes that are put on fruits and candies to help preserve them, the non-stick coating on your cookware, again, plastics we mentioned, detergents, your shoes, the toilet seat that you sit on, vinyl and plastic that we mentioned, those windbreakers, those coats, polypropylene coats, your heating oil, your CDs and your DVDs, your components to your television sets, blenders and small appliances, your flooring, and things that make up your electrical appliances. And that's just a few of the things that we have petroleum in. So the United States, I was saying, consumes about 1/5 of the world's oil, but rapidly industrializing populations like China and India are increasing and driving the world demand. So they're putting more demand on that. Okay, this is where we're going to end. We're about 14 minutes in, and I will see you on the other side. Bye.